The Amazon rainforest is home to strange weather. One peculiarity is that rains begin 2 to 3 months before seasonal winds start to bring in moist air from the ocean. Now, researchers say they have finally figured out where this early moisture comes from: the trees themselves. The study provides concrete data for something scientists had theorized for a long time, says Michael Keller, a forest ecologist and research scientist for the U.S. Forest Service based in Pasadena, California, who was not involved with the work. The evidence the team provides, he says, is the smoking gun. Previous research showed early accumulation of moisture in the atmosphere over the Amazon, but scientists weren't sure why. All you can see is the water vapor, but you don't know where it comes from, says Rong Fu, a climate scientist at the University of California, Los Angeles. Satellite data showed that the increase coincided with a greening of the rainforest, or an increase in fresh leaves, leading researchers to suspect the moisture might be water vapor released during photosynthesis. In a process called transpiration, plants release water vapor from small pores on the underside of their leaves. Fu thought it was possible that plants were releasing enough moisture to build low-level clouds over the Amazon, but she needed to explicitly connect the moisture to the tropical forest. So Fu and her colleagues observed water vapor over the Amazon with NASA's Horus satellite, a spacecraft dedicated to studying the chemistry of Earth's atmosphere. Moisture that evaporates from the ocean tends to be lighter than water vapor released into the atmosphere by plants. That's because during evaporation, water molecules containing deuterium, the heavy isotope of hydrogen made of 1 proton and 1 neutron, get left behind in the ocean. By contrast, in transpiration, plants simply suck water out of the soil and push it into the air without changing its isotopic composition. Nora found that was the early moisture accumulating over the rainforest was high in deuterium, too high to be explained by water vapor from the ocean, Fu says. What's more, the deuterium content was highest at the end of the Amazon's dry season, during the greening period when photosynthesis was strongest. The tree-induced rain clouds could have other domino effects on the weather. As those clouds release rain, they warm the atmosphere, causing air to rise and triggering circulation. Fu and colleagues believe that this circulation is large enough that it triggers the shift in wind patterns that will bring in more moisture from the ocean. They report in the Proceedings of the National Academy of Sciences. Scientists have studied the connection between trees and rain in the Amazon before. A 2012 study found that plants help seed the atmosphere for rain by releasing tiny salt particles. But the new study strongly supports the idea that plants play an important role in triggering the rainy season, says Scott Salesky, an ecologist at the University of Arizona in Tucson, who was not involved with the work. The deuterium provides a clear fingerprint for what plants contribute to the process, he says. The findings also address the long-standing debate about the role plants play in weather. says Salesco, suggesting that they are more than just passive recipients, and that they instead can play an active role in regulating rainfall. If that's true in the Amazon, Salesco says, climate scientists will need to take into account practices like deforestation when predicting regional changes in weather patterns. And curbing deforestation will be an important step for people to take in preventing drought. Next, Thu will be studying rainforests in the Congo, to see whether the same process is happening.